with the word or in between. And or means I add, right? With or in between. So if I take one card, what's the probability that it's red or a king? So it's one card. So this is also mutually exclusive events, is one event happening. Now, when two events are mutually exclusive, they are disjoint sets. That means they have nothing in common. So if they're mutually exclusive, a Venn diagram that's mutually exclusive would have two circles that do not overlap. No overlap for mutually exclusive. Everyone paying attention? So mutually exclusive is no overlap. So if I pull a card out of a deck and I ask you what's the probability it's black or red, are those events mutually exclusive or not? They are mutually exclusive because black and red, there's no overlap, correct? But what if I said I take out a card, what's the probability that it's black or a club? Not mutually exclusive because all clubs are black, actually. There's a ton of overlap. Okay? So mutually exclusive means no overlap and they're disjoint. Not mutually exclusive. Means there's overlap. And a Venn diagram would just be a plain old normal Venn diagram. That would be not mutually exclusive because there would be some things that are in both, right? Now, if I was talking about the card one that I was talking about, and I said clubs or black cards, if this was black cards and this was clubs, I would actually have 13 in here. Why?
Because
all the clubs are black. I'd have none that are just clubs. And then I would also have 13 cards here. Why?
Because there's 26 black.
There's 26 black cards, 13 are spades, right? So this would be not mutually exclusive because there's overlap. Yeah?
I forgot that unit. If there's nothing in there, do you have to put 0? Or do you
Yeah, we put 0.
Okay.
All right. These are the formulas we can use. If they're mutually exclusive, we have the probability of A or B. Remember, it's the word or that matters. Then you add them. That's if they're mutually exclusive. If they're not mutually exclusive, and these are on your formula sheet there, the top two, mutually exclusive, not mutually exclusive, it's alphabetical, mutually, not mutually. If they're not mutually exclusive, you actually have to add the two probabilities and then subtract off the overlap. Now, why would that be? Well, let's think about it. If I do probability of black cards or clubs, I would do probability of black cards, or means add, probability of clubs, and then I have to subtract off the black cards and clubs, because guess what? I counted the black cards and clubs here. I also counted the black cards and clubs here. I've counted them twice. So I have to take them back off because I've technically counted the cards twice now. Because black cards probability would be 26 out of 52. And then the clubs are 13 out of 52. And then I have to take off the black clubs, which are 13 out of 52. Because I counted the black clubs in the 26 already, and then I counted them again. So I have to take off the overlap. So it'd be 26 out of 52. Or 1 out of 2. So what's the probability on black or a club? Half. Which makes sense, because the blacks are half of it. Okay. Then we're going to flip over to the next one. So here, I have a spinner numbered 1 to 10 is spun. So that's one of those like high plates, and they have like a little arrow on them, and you spin them, and the spinner spins, right? They're numbered 1 to 10. Each number is equally likely. So that means that each piece, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, is the same size, right? So it's the same chance of being spun. What is the probability of spinning? An even number or a factor of 3. So we have to discuss if they're mutually exclusive or not. Whenever we get this, when we see or, we have to decide if it's ME, mutually exclusive, or not mutually exclusive, because we use different formulas, right? If it's mutually exclusive, we just add the two probabilities. If it's not mutually exclusive, we add the two probabilities and subtract off the overlap. We use these two formulas. Is the mutually exclusive formula? It's the not mutually exclusive formula. So we have to decide, is there overlap? So what are the even numbers of 1 to 10? 2, 4, 6, 8, 10. Which are the factors of 3? Factors of 3.
2.
Nope, 2 numbers that multiply to give you 3 are factors. 1 and 3. Are any of these overlapping? So what is this? Mutually exclusive means no overlap. Yes? And the mutually exclusive formula is to just add the 2 probabilities. So I'm going to do the probability of even, or, so plus the probability of a factor of 3. And I don't have to subtract off anything because there is no overlap. So what's the probability of even? Everyone paying attention or you're going to be lost. What's the probability of even? So 5 out of 10. Probability of a factor of 3? 2 out of 10. And when you add fractions to common denominators, you get that fraction denominator again. What goes on the top? 7. That's it. So I want you to try B, C. Go. You have to first decide if it's ME or NME. So, or is the big decider of mutually exclusive or not mutually exclusive. When we have and, it's going to, tomorrow, it's going to be independent and dependent. So, or is mutually exclusive or not. So we have to decide. Odd numbers. 1, 3, 5, 7, 9. Multiples of 3 are 3, 6, and 9. So is there overlap or not?
Yep.
There is. So this is not mutually exclusive. And if it's not mutually exclusive means nothing in common, right? No overlap, totally separate circles. So this one has overlap. It's the 3 and the 9, right? So when it is not mutually exclusive, I have to do probability of an odd number. I have to do the second formula. Probability of an odd number plus the probability of a multiple of 3. And then I have to subtract off the overlap. Probability of an odd and multiple of 3. So those numbers that are counted twice, right? If I don't take it off, I'm counting the 3 and the 6 in both of those probabilities. It'll be way bigger. Okay? So how many odd numbers are there? 5 out of 10 plus multiples of 3. 3 out of 10. Now how many of them actually are the same? 2. So I counted the 3 and the 9 in the first probability. I counted the 3 and the 9 in the second probability. So I have to make sure to take them back off so I didn't count them twice. So 2 out of 10. So I get 6 out of 10, which reduces to 3 out of 5. And remember, you can go 6 divided by 10, math, enter, and it'll reduce it for you. The calculator. Yeah, 1 to 10 is 10. Okay, here we have a number less than 8. So 1, 2, 3, 4, 5, 6, 7. A divisor of 15. That's something that you can divide into 15, bless you. That comes out without decimals. So 3, 5. That's it. Mutually exclusive or not? Yeah. Yep. Call. Are these mutually exclusive or not mutually exclusive? Mutually exclusive is no numbers overlap. Not mutually exclusive is overlap. So which one is it?
Not.
Because actually all of them overlap. You see that? So we have to do probability of less than 8. Or means I add. Probability of a divisor of 15. And then I have to subtract off the probability of less than 8 and divisors of 15. So I always subtract off the overlap. So if there's overlap, you have to subtract it off. Key, that's the key thing here when there's an or. Okay? So less than 8, how many of them are there? Don't all answer at once.
7.
7 out of
7.
10. And then divisors of 15. 3 out of 10. And then I have to subtract off the overlap. 3 out of 10. So I actually get 7 out of 10, which I could answer as 0.7. depending on what type of answer they want.
Wait, 1 minute.
10 numbers, 1 to 10. Spinner has 10 numbers. Yeah. Yeah.
Don't be a judge.
That's all they are is judges over there. Judges. Judgerito.
We really don't.
Calls me that.
Actually, rich. We are so nice. We lift people up.
Don't be a judger, guys. Don't be a
We
judger.
don't.
Yes, I agree completely
I feel like
with everything you are saying. All right. Example 4.
I just feel it.
Example 5. Try these out. Now look here. This one is decimal probabilities, and it sounds like a Venn diagram. This one is just a normal Venn diagram. So what do decimal probabilities have to add up to on a Venn diagram? 1. Percents have to add up to 100, right? So try this out. Example 4 and example 5. Go. This one here has the probability that Eric will play golf this weekend is 0.5. The probability he'll play tennis is 0.3. Probability he will do neither is 0.2. It sounds very Venn diagram-y, right? But it says probability, so it's going to have to add to 100. So we know that we have 2 circles, possibly with overlap. So they might be mutually exclusive, they might not be. We have tennis and golf. And we have neither. Now, I gave you the singles and the neither. Remember, what do? We take all 3, add them up, and subtract it from the total, correct? What's the total on a probability Venn diagram? 1. So if I go 0.5 plus 0.3 plus 0.25, I get 1.05. How much more than 1 is that? 0.05, right? So that's going to be my overlap. So if I want tennis only, I subtract 0.3, or take 0.3 and subtract 0.05, so I get 0.025. 0.25, I mean. And then golf is 0.5 minus 0.05, so 0.45. Then it says the probability that he will do at least one of those activities. So that's the whole Venn diagram, right? Like the whole circle. So it'd be 0.75. And then this one says the probability to the nearest 100th, he will play tennis and golf. That's the eyeball. And is the eyeball, right? So 0.05. So that's a probability Venn diagram because it says probability. So I just get the probabilities right from it. This one's a plain old diagram. So your plain old Venn diagram, to get the probability, you're going to have to divide it by the total number of people when you find your Venn diagram. So in this case, we're going to have to divide it by 80. So we have 80 people total, 40 liked cornflakes, 22 liked both cornflakes and oatmeal, 20 children liked neither. Let's do a Venn diagram. So we have cornflakes, oatmeal, 22 liked both, 48 liked cornflakes. So how many like cornflakes only? 26. And then there's 20 who liked neither. When I add that up, I get 68. So how many liked oatmeal? 12. Because it has to add to what? 80. Now if they ask me for the probability of anything, I'm going to have to take whatever numbers from my Venn diagram divided by 80. Because divide by the total. Probability Venn diagram, the one above, gives you the probability right away. These ones you actually have to find the probability. So this one says the probability to the nearest 100th. Doesn't say 100%. So I just take what it is and round it. Not times by 100. That a child selected at random from the group liked only oatmeal. So it can be 12 out of 80, which is 0. What?
1.5.
Okay, then we're going to flip over. So once again, this is just a normal Venn diagram, correct? So if I'm on probability, I'm going to have to divide by 100 this time because there's surveyed 100 people. If they surveyed 500 people, I divide by 500. So a travel agency surveyed 100 people who cycle or ski. It said 17 cycle and ski, 29 ski, so that would be 12 ski only. 68 cycle, so that is 41? 51?
51.
Yep, realized after I wrote the 4. Is it gonna, oh yay, it didn't delete everything. And then how many are on the outside?
20.
So here it says, what is the probability the randomly chosen individual from the above 100 cycles only? So probability of cycling only. How many cycle only?
51.
Out of?
100.
So 0.51. Okay. Last question we're going to go to. This one, you have to spot these when you see them. Everyone paying attention? This one says Dominic and Laura are playing a board game. To move a turn, Dominic must roll either doubles or a sum of 7. So we're rolling 2 dice, correct? Are we doing that?
Yes.
So whenever we roll 2 dice, 2 6-sided dice, I always draw an array. And some people are like, I'm lazy, I don't want to. Cool, you might get the question wrong. So I never. So I have 1, 2, 3, 4, 5, 6. So I list them. Everyone's doing this.
Yep, I am.
And then on this side I have 1, 2, 3, 4, 5, 6. Okay. So this one talks about sums. So I'm going to put the sum of the dice in the middle. So this one would be 2, 1 and 2 is 3, 1 and 3 is 4, 4 and 1 is 5. Do you see how I make them a different color? So I don't get the 1 to 6 on the outsides mixed up with my actual outcomes. 1 and 5 is 6, 1 and 6 is 7, 2 and 1 is 3, 2 and 2 is 4, 5, 6, 7, 8. 3 and 1 is 4, 3 and 2 is 5, 6, 7, 8, 9. 4 and 1 is 5, 6, 7, 8, 9, 10. 5 and 1 is 6, 7, 8, 9, 10, 11. 6 and 1 is 7, 8, 9, 10, 11, 12. So I just put all the sums on there, right? So here it says to move a turn, Dominic must roll either doubles or, here's that word or. Or means mutually exclusive or not mutually exclusive. When I get probabilities with the word or, and I have to figure out which one it is, right? So it's doubles or a sum of 7. So are there any doubles that sum to 7? I have 1, 1, which is 2. 2, 2, which is 4, 3, 3, which is 6, 4, 4, which is 8, 5, 5, 10, 6, 6, 12, right? So do any of them sum to 7? No. So is this mutually exclusive or not mutually exclusive? Is it mutually exclusive or not mutually exclusive?
Mutually exclusive.
Mutually exclusive because there's no
Overlap.
overlap. They're separate. So if it's mutually exclusive, if I do the probability of a double or a sum of 7, I'm going to get the probability of a double plus the probability of a sum of 7. So how many make doubles? Yeah, 1, 2, 3, 4, 5, 6. Because that would be 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, right? So this would be 6 out of how many? 36. Sums of 7. 1, 2, 3, 4, 5, 6. If you didn't know if there was overlap or not, did any of my circles overlap with any of my lined ones? No, so that's a giveaway that it's mutually exclusive, right? None of my circles and the ones that I underlined actually cover with each other, right? They're completely separate. So there's no overlap. So this one is 1, 2, 3, 4, 5, 6 out of 36 as well. which gets me 12 out of 36, or 1/3. Okay? Tomorrow we're finishing up the last lesson of the year. We do still have rational word problems, but we're doing those in January. Very first day you're back.
Wait.
No, you have to. You're always on the diploma.